second quarter. So we are expecting some immediate results. So we are expecting that sales would increase once we go from quarter 1 to quarter 2. So now here we are comparing Q1 sale with Q2 sale. So our hypothesis is average sale of the second quarter, or we should write in the form of suffix only. We say that average sale of the second quarter equals to average sale of the first quarter. Why we put equals to? Because it is being demanded as per the definition of null hypothesis. So if this is the thing, means there is no increase in sale. Since there is no increase in sale, means advertisement is a failure. Right? And what would be the H1? It is opposite to this. There is increase in sale. Advertisement is a success. Means average sale of Q2 is greater than average sale of Q1. Right? This test also involves two samples, one from Q1 and one from Q2. So this is also known as two sample test. Now if we compare second and third, what is the difference in between these two? The difference is here the two samples, rural and urban, are separate. If unit belongs to the rural area, it may not belong to the urban area. So this is actually known as two independent sample test. Deliberately, I put a gap. We will be discussed later on. And this second situation is known as two dependent or related sample test. This is also known as paired test. Okay, so this is the another example. Now we will be taking one more example here. Now we are examining, means there is a claim or there is a saying that all the four regions or all the four locations have equal sales, right? So it is being propagated as that average sale, four locations are northern, eastern, western, southern, as per the data. So we say mu n equals to mu e equals to mu w is equal to mu s, right? So if we say this, then we say that this claim or this perception is right. The other one is claim is wrong. So for claim to be wrong, it is not necessary that all are unequal. Even if north, east, west are same, southern is different, then H0 won't be there. If all are different, it won't be there. It might be possible that north and eastern are same, but and western and southern are same, but they are different from each other. So there will be a number of cases. This is known as, so we write H1 as at least one mu I is different from others. Right? So these are the four examples that we are discussing. So now floor is open. If any question or anything you like to ask, here I have taken example. And this type of test is known as, let me write the name of this test, This test is known as K-independent sample test. So any question? Yes, participants, any question? Because this is the important part, formulation of the hypothesis. And it
Sir,
is
if it is more than three or two or
okay.
four
Okay.
alternatives.
No, why should we have more than two? Right? Okay. Like this not equals to means it can either be greater or it can be less. Like we take an example. Suppose someone says that this value cannot be 75, means it can be greater than 75, it can be less than 75, right? Or consider a shopkeeper. The shopkeeper is using a box of 1 kg. So shopkeeper would never be interested that there would be more than 1 kg of the material in the box, as well as it cannot afford to have less than 1 kg amount in the box. Otherwise, there will be a raid from the enforcement agencies, etc. So for a shopkeeper, it is important that the amount would be exactly equal to the 1 kg. So shopkeeper would be using not equal to alternative. But for a shopper, for a consumer would be bothered only if the amount is less than 1 kg. If that consumer is getting more than 1 kg, so obviously there won't be issue, right? So actually three signs are possible. It can be greater than, it can be less than. And if we don't go with the sign, means it is immaterial whether the things are greater than or less than, then we will be using not equals to. So this not equal to type of test is known as two-tailed test, because here both tails are involved. This is known as two-tailed test. And this greater than or less than, this is actually known as one-tailed test. Okay, is that okay? Hello?
Yes, sir. Yes, sir. Yes, sir.
Any other question? Obviously, with different concepts, like in regression, hypothesis would be different, but the base concept remains the same. So hopefully there is no question. So can we move forward? Hello? Okay, right. So now here we are discussing the testing procedure. There are 5 steps. The first and the foremost step is setting the hypothesis. Here I have taken some examples. So in H naught, it can be strict equals to, it can be less than or equals to, or it can be greater than or equal to. Means we will always have one type of equals to is there. But in H1, there is not equal to sign. Mean it is either greater than, strict greater than, or strict less than, or not equals to. Not equals to contains both the things. So how we define the test? Test is actually the statistical rule or the process to decide whether to reject or to retain the hypothesis. Okay, this part we are not discussing because here I am delivering this lecture through a software. So I am not using that part. We have one tail test and two tail test. This I have covered. This is also we are not covering. Now this is important. Now, as we have discussed earlier, that we examine whether population is normal or not. This we did yesterday. So if population is normal, then we use the parametric test. So it requires the assumption that population distribution is following normal distribution. If population distribution is not normal, we will be using non-parametric test. So here, assumption is strict. And here there is no assumption. So non-parametric tests are more generic. They can be used in a general situation, but they are less efficient. The level of error would be high. But the parametric tests are more efficient, their power is more, but require the fulfillment of the assumption. So we always say that we can never get everything in the life. So parametric tests are better, they are more efficient, but in order to apply the parametric test, normality assumption must be there. Normally, when we don't have the normality assumption, we go for the non-parametric test. Right? And then we decide level of significance. Normally, we decide level of significance as 5%. Though this is not strict, this was discussed earlier also. It can be greater than 5%, it can be less than also. Then we take sample and we decide the rejection or otherwise. Here I am taking up the second aspect that is used in the software, right? We remember in the earlier, I have explained the concept that we go with the probability. We examine whether the probability is large or probability is small. If probability is large, we don't reject. If probability is small, we reject. So this probability is technically known as p-value or the probability value, right? So if p-value is small, less than alpha, that is the 5%, we reject H naught. Otherwise, if p-value is also written as Sij, is greater than alpha, normally we go with 5%, then we do not reject H naught or we accept H naught or retain H naught. So this is the testing procedure that we are going to do. This I will be demonstrating through the SPSS. So any question up to this point? The testing process is broadly clear. It will remain for all the multivariate data also. Only the test type would be different. Okay. Now I am coming back to this example. Here, yesterday we have made the correction. So now it is clear that you can check also that all the quarters Q1, Q2, Q3 are normals, right? So here in this example, I am taking an assumption. And what is the assumption we are taking? You can check this again. Assumption that we are taking is all quarters data like Q1, Q2, Q3, Q4 are following normal distribution. Since they are following normal distribution, so in this example, we will be discussing parametric tests. If they don't follow the normal distribution, then we will be discussing non-parametric tests. So initially, we discuss the parametric test, then we go to non-parametric test. So here, we will be using one sample t-test. Right? It won't be there with this name when we consider the non-parametric part. So in that case, name would be different that I will be introducing. So this is known as one sample t-test. This test is known as two independent sample t-test. So this t-test is used when we have one sample or two sample. Right? So the third example also, this is known as dependent sample t-test or paired t-test. Right? So t-test can be used only for one sample and two sample. And if we have three or more, then we use another concept that is known as ANOVA or analysis of variance. So at the first go, we are discussing these tests. Okay, and they are there in the slides also. Okay? These are the tests that we are going to perform through SPSS. Any question up to this point? Now, we will be moving to SPSS part. So, concepts are clear? Yes, participants?
Yes, sir. Yes, sir.
Okay. Thank you. Now, I am opening this SPSS sheet. Here, kindly make a correction. In case number 55, Yesterday we have 611. That was an error. So kindly correct that. Put that value as 61. Otherwise, you will be getting different results. Is that okay? Right. So now the first test we are going to perform, that was the claim that in the first quarter the sales are 75. So all the analytical tools are available under the drop menu of analyze. So we click analyze, then we go to compare mean. So in the compare mean, all the tests that are there belongs to the parametric test part. And if normality assumption is not being fulfilled, we go to the non-parametric test. Right? This is a non-parametric test. Then we go to the legacy dialog. Then we can select these non-parametric tests with the same name: two independent sample, k independent sample, two related sample, and so on. Anyway, we are using compare mean. And in the compare mean, we are considering one sample t-test. So this dialog box is visible, participants, class,
Yes, sir.
right? So as I have mentioned yesterday also, in all the SPSS analysis, this dialog box remain more or less same. Here, we are selecting the first quarter. So we are selecting the sales of the outlet in the first quarter. This is known as test variable. And the test value is the value of the null hypothesis. We are examining it for 75. So here we enter 75 and then we press OK. Right? So this is, let me save this. This is output 19. So now from the sample, we are getting a value of 72. Now we examine whether this value 72 is significantly different from the hypothesized value of 75 or not. And this is being done by this test that is known as one sample t-test with a test value of 75. Right? So here, if we observe the p-value, that is the significance. The significance two-tailed value is 0.021. And this 0.021 is less than 0.05. Less than 0.05 means we are rejecting H naught. We are rejecting H naught means the claim is wrong, that in the first quarter average sale is 75. This is not 75. Right? This I will be writing on the whiteboard. So let me complete that. Then you people, if you want, you people have a screenshot of this. So that will be easy for the reference purpose. You can have a screenshot of this, the output, because I am changing it to the done. Hello.
Yes, sir. Done.
Okay. Right. So actually we are discussing this test, right? Now it is there, whiteboard is there, claim of Q1 that average sale is 75. We are testing this and the test is one sample t test. So here I am writing that again. H naught is mu equals to 75 versus H1 as mu naught equals to 75. Remember, this is not equals to, so this is known as two-tailed test. And as per the output, our p-value is significance of two-tail. I have just shown you is 0.021, which is less than 0.05. So we reject H naught. Means the claim that sales in Q1 is 75 is incorrect or wrong. Right? So is it clear? Is it clear?
Yes, sir.
Now we are considering the second situation. What is the second situation? Perception that rural outlets are giving higher sales as compared to the urban outlet. So this is for the comparison purpose. And here we will be discussing two independent sample t-tests. This is the hypothesis that I will be writing again on the next sheet. First, I should run the test, and after that we can discuss. And we are running this just for the demonstration purpose. I am running this test for Q3 data. This is just for the demonstration purpose. You can run for another quarters also. Okay. So now we go to SPSS sheet is there. Now we go to analyze, then we go to compare mean, and through the compare mean we go to independent sample t-test. Remember the name, independent sample t-test. So we will be selecting independent sample t-test. We will click on this. This is independent sample t-test. Now the test variable, just for the demonstration purpose, I am taking sales of the outlet in the third quarter. This is the test variable. And for grouping, we want group as per urban and rural. So they are there in the type of the outlet. So we will be selecting type of outlet and entering them into this box, that is a grouping variable. Now as we entered, it is asking us to define the group. We can define the group. First group is 2, the second group is 1, because 2 is the code for urban and 1 is the code for, 2 is the code for rural and 1 is the code for urban. Now remember, t-test is a symmetric test. T-distribution is a symmetric distribution. So the left tail and the right tail both remains the same. So it is immaterial whether you select group 1 as 1 and group 2 as 2, or you select group 1 as 2 and vice versa. So it is immaterial. You can select anyone. Now from this sub dialog box, I am moving to main dialog box by clicking continue. So this OK got highlighted. I click this OK. Now this is the t-test. Right? Now here we are having the sample results. Means rural outlets are giving average sale of 64 and urban outlets are giving average sale of 61. So we examine whether there is a significant difference between 64 and 61. So for this purpose, we are interpreting independent sample t-test. Right? Now here in the output, our main objective was t-test for equality of mean only. This is our main objective. We want to test this only. Right? But there is one more option, that is the Leibniz test of equality of variance. Why this is there? Now, if you read these two lines, the first line is related to equal variance assumed. So if we have equal variance, then our p-value or significance is 0.149. And if variance is not equal, right, means we are going to the second line, then the corresponding p-value or significance is 0.115. So the question arises whether we should use 0.149 in our interpretation or we should use 0.115 in our interpretation. Remember, this 0.149 would be used if we have equal variance, and this value 0.115 would be used if we don't have equal variance. So the first step is to examine whether variances of two groups are equal or not. So for that purpose, we would be interpreting Leibniz test of equality of variance. So if you see the p-value of Leibniz test of equality of variance, this p-value is 0.052 and this 0.052 is greater than 0.05. Since this value is greater than 0.05, so we say that variances are equal. Since variances are equal, so in between these two values, 0.149 and 0.115, we will be selecting 0.149 for our interpretation. Right? So this I will be doing on the whiteboard. So you people can have a screenshot of this output so that easy to be referred. Once I explain the concept on the whiteboard, then I will be taking the question if there are sum. Have a screenshot? Done?
Yes, sir.
Okay. Right. So here now I am discussing this second case. So for the second case, now I am discussing the case 2. Case 2 is we are comparing mu r with mu u versus mu r is greater than mu u. Remember, this is a one-tailed test because it has greater than or less than. It is immaterial whether you put greater or you put less. Remember, this is a one-tailed test. Right. Now, here I will be using the two independent sample tests at is there. But here we have two outputs. One for equal variance. Here we have two p-values. For equal variance, the p-value is 0.149. Remember, this significance is for two-tailed. And for unequal variance, the value is 0.115. Now the question arises whether we should select, just a moment, let me, the first value is for equal variance and the second is for unequal variance. So the value is 0.115. Now the question arises which value we should take. So to decide this, we would be interpreting Leibniz test. So this Leibniz test is not directly part of this t-test. It is used just to decide whether the two groups are having equal variance or not. Because as you follow the notes, right? This is for when population SDs are unknown but equal. Right? This is for equal variance. This case is for equal variance. So we have different test statistics, and this is for unequal variance. So we will be using the different formula set for the two situations. That's why we will be having two different tests. And this is the Leibniz test, which is used for equality of variances. This is the Leibniz test that I am mentioning. So they are there in the notes. So the Leibniz test for equality of variance. Here the p-value as per the output, if you have the screenshot, this is 0.052. This is greater than 0.05. So we say that two groups are having equal variance. Right? If the p-value is less than 0.05, then we say the two groups have unequal variance. Since they have the equal variance, so we will be selecting this and we are deleting this because we don't have the equal variance. Now, further, this p-value is for the two-tail, but we require the p-value of one tail. So they are related also. And what is the relationship? Here I am writing that the p-value of two-tail test is equals to twice of p-value of one-tail test. This is the next concept. Right? So here we are having the p-value of two-tail, but actually we require the p-value for one-tail. We require the p-value or significance for one tail because here we have greater than not equals to. So how that can be done? We divide 0.149, which is for the two tail, by 2. So we will be getting 0.075 approximately. Now this value is to be compared with 5%. This is greater than 0.05. Greater than 0.05 means we do not reject H naught, means we retain or accept H naught. What does this mean? It simply says that there is insignificant difference between the urban outlet sales and the rural outlet sale. So the claim that rural outlets are giving higher sale is not correct if we consider the Q3 data. Right? So any question up to this point? So we have discussed the two tests so far. If there are some questions, I can take. Otherwise, I will move forward.
Sir, can you repeat that 2 into p value of one tail test?
Okay. The concept is p-value of two-tail test is equals to twice of p-value of one-tail test. So here the output is given. Obviously, any software will give output related to either two-tail or one-tail, but we can always convert it to the another case. So as per the output, the p-value of two-tail test is 0.149. So p-value of two-tail test is 0.149, and we require p-value for one tail. So what would be the p-value or significance of one tail? It will be the p-value of two tail divided by 2. So 0.149 divided by 2, we are getting 0.075. This value is greater than 0.05, so we are not rejecting, we are retaining the null hypothesis. Is that okay?
Okay, sir, but why we are not applying that in the first case?
Why we don't apply in the first case? What is H1? Not equals to. So this is a two-tail test, right? So we are directly taking the two-tail test. Right? It depends upon the H1 whether the test is two tail or one tail. This I have explained here
Yeah,
also.
okay, sir. Clear.
Right?
Okay.
Is that okay?
Yeah.
Right, so that's why I have taken different type of example. So both the cases may be covered. And for the p-value, it is immaterial whether you are considering right tail or left tail. Both are one tail only. And the probability is always positive. So it is immaterial whether we are considering right tail test or the left tail test. Fine?
Yes, sir.
Okay. Now we are considering the third example. Third example was an advertisement campaign is being launched in the beginning of the second quarter. So we are expecting a higher sales in the second quarter as compared to the first quarter. So in the third example, we are comparing average sale of the second quarter versus average sale of the first quarter. If this is the case, then we say that advertisement campaign is a failure. And our H1 is average sale of Q2 is greater than average sale of Q1. If this is the case, then we say that there is success. Again, this is greater than, so we will be using one tail test. And here, as we discussed earlier, we will be interpreting, we will be using pair t-test. So now I am demonstrating the application of pair t-test. I'm changing the slides. So SPSS output is there, class?
Yes, sir.
Okay. So we go to analyze, then we go to compare mean. Compare means mean parametric test. And in the compare mean, now we are selecting paired sample t-test. So this is very important. We should clearly recognize whether we are going to use independent sample t-test or we are going to use paired sample t-test. So software does only that thing that is being instructed. So it is the responsibility of the researcher or the analyst that the proper instruction should be given. So that's why we focus so much on the concept, because if concepts are wrong, then software will only do what is being what the software is being instructed. So it is very important to instruct correctly. Now here we will be using pair t-test. So this is the dialog box of the paired t-test. Here we are having pair. Now Again, we are using t-test, so it is immaterial whether we use first quarter as variable 1 or second quarter as variable 1. It is immaterial. Okay, so we are selecting sales of the outlet in the first quarter as well as sales of the outlet in the second quarter, and then we press OK. Right? So this is the pair t-test. So as from the sample data, the average sale of the first quarter is 72.02, average sale of the 1000, average sale of the second quarter is 72.43 thousand. So there is a difference. We examine whether this difference is significant or not. So for that purpose, we will be interpreting paired sample t-test. Now you people can have a screenshot of this. Remember here, the p-value for the two tail is 0.688. So we are dividing it by 2. So I have a screenshot of this. Done? So now I am interpreting this. Okay. So as per the output here, the p-value or significance for two-tail test is 0.688. And this is a one-tail test, so we require significance of p-value for one-tail test. So it would be 0.688 divided by 2. We are getting 0.344. This value is greater than 0.05. Greater than 0.05 means we are not rejecting, we are retaining or accepting H now. Means there is no significant increase. There is no significant increase. So we can say that advertisement campaign is a failure. Right? Before I take the question, I am repeating it. Remember in the case, if you people have the case, you must have the second statement, last statement. A sales promotion program was also launched in the beginning of the fourth quarter. Right? So along this, I am discussing one more situation just to repeat this test for sales promotion also. So I am just repeating this for Q3 and Q4. So I am repeating this for third B case. We are examining effectiveness of sales promotion program. Means we are comparing Q3 and Q4. So now H1, H0 would be mu of Q4 equals to mu of Q3. It means there is no increase. So we can say that sales promotion is not a success, is a failure. And H1 is that sales promotion is a success. We write mu of Q4 is greater than mu of Q3. So we are just repeating our pair t-test. Okay, this is just to repeat. Right, so I am just repeating this. We go to analyze, then we go to compare mean, and we go to pair t-test. We reset, and now we select Q3 and Q4. We select Q3 and Q4 and repeat the test. Okay. Now, as you see here, the sales of the outlet in the third quarter is 62. Sales of the outlet in the fourth quarter is 74. There is a difference. We examine whether this difference is significant or not. So as you see here, the p-value is 0.000. This is for two tail. Means there is no number up to the first three places after decimal. So if we divide it by 2, there will be further lower value. So this value is less than 0.05, means we are rejecting. So you people can have a screenshot so that I may go to the whiteboard. Have a screenshot of this also. Done? So here, as per the output, the significance for two tail is 0.000. So the significance of p-value for one tail would be 0.000 divided by 2. It will remain 0.00 or less. So this is less than 0.05. Less than 0.05 means we reject H0, means there is a substantial increase. There is a significant increase. So we can say that sales promotion is a success with the caveat provided all other things remains the same. Okay? So this is just a repeat of pair t-test. So any question, kindly ask. Otherwise, we will be moving to the next situation. Any question? Okay, the question is, yes, I am taking these two questions one by one, right? So what is the difference between independent sample t-test and the pair t-test? Independent sample means when samples are drawn independently, they have no connection. So means there is nothing common in between them. Like in the first case, one sample is from the rural area, one sample is from the urban area. So they are the independent sample. But when we compare whether advertisement is putting a success or not, right? So in that case, let me show you, just a moment. Let me show you the data set, right? So for a good comparison, right, like Q1 and Q2, we are comparing the Q1 sale of the first outlet with the Q2 sale of the first outlet only, right? We cannot compare the Q1 sale of the first outlet with Q2 sale of the second outlet. Why we cannot compare? Because it might be possible that they are placed differently. If something is at the road head, obviously that is giving higher sale. If someone is in the interior, it is not giving the lower sale. I will be taking one more example. So to explain that, suppose we want to know whether this workshop has increased the research aptitude or the statistical aptitude of the student or not. So how that can be done? So before the start of the test, the start of the workshop, one aptitude test is given. And after the completion of the workshop, another aptitude test is given. And then we compare, right? Then obviously when we compare, so we will be compare then uh, score of Nisha with Nisha itself, score of Janapriya with Janapriya itself, score of Mohsin with Mohsin itself. Means if we consider Dr. Mohsin, so what is the previous score of Mohsin is to be compared with the past score of Mohsin, Dr. Mohsin only, right? Why? Because everyone may be at the different pedestal and everyone may belong to some different background also. So to balance that background, we will be using pair t-test. So is it clear? Is it clear? Okay. And the second question is why we put H0 as a null hypothesis, or why we put H0 as no difference or the negative statement, because H naught is used for the nullification purpose, and all the tests are being made with respect to considering H naught. That's why reject H naught is the main thing. So all tests are being meant, so reject the H naught. And if we fail to reject the H naught, then we have to accept the hypothesis. That's why, as an statistician, we avoid using the word accept H naught. We always say that we fail to reject H naught. So this is the reason that the null hypothesis is given a negative statement. So Miss Janapriya, is it okay? Yes. So any other question or we should move forward?
Sir, any number of sample is fixed for this t-test? Any number of sample or greater than or less than sample, then we do the t-test.
Okay, sample size or
Yeah, size, number of
size.
sample size.
That I have discussed earlier also, right? Actually, the t-test, there is a misnomer. Normally people relate the t-test with the sample size. This is a misnomer. This t-test is used whenever the population SD is unknown. So in all the real data set, population SD is never known. So that's why in SPSS we don't have the Z-test. So Z-test is used only if the population SD is known. Earlier, when we don't have the support of the software packages, we use the tables from the book. So that table for the t-test is an exact test, right? So suppose sample size is 100. So we have to provide a table for the t-test for the 100, 200 or 500 sample size. So for that test, for that situation, we put the central limit theorem and we put the statement that when the sample size is large, then the t-test can be approximated by the z-test. So we say only the approximation, not the real thing. So the concept is whenever population SD is known, which is the thing in all the real data set, then we will always use the t-test. So it is immaterial whether the sample size is 20, 30, 50 or 100. Okay, accordingly the values will be changed.
Okay, thank you.
Okay,
Thank you.
right. So questions done. So should we move forward? Okay. Now, right. Now I am discussing the last situation. This is all four regions or location have equal sales or not. Okay? Now this is the fourth situation that I am discussing now with the H naught as mu of northern region is equal to mu of eastern, average sale of the eastern is equal to average sale of western is equal to average sale of southern. And H1 is at least one mu is different from others. So this is known as K independent sample. Why independent? Because the outlet belonging to the northern region may not belong to the eastern region. So they are different. And here the value of K is 4, that is greater than 2. So for this purpose, we will be using one-way ANOVA. ANOVA full form is one-way analysis of variance. So remember this ANOVA, though the name is analysis of variance, but this is used for comparing of mean. Just a moment, I am taking a call. Just a moment. Okay, so this is for analysis of variance, but it is used for comparing mean. Why this is used for why this name analysis of variance, but it is used for comparing mean? This we will be discussing with this example. Okay, right? So this is important. So now I'm changing it to data sheet. Right? Suppose we are considering data for Q3. Right? So SPSS sheet is there, participants. Is it there?
Yes, sir.
Okay. So if we consider the Q3 sale, values are 62, 53, 69, 77, and so on. So if we observe that these values are different. So we say that there is a variation. And remember yesterday I have told that there are two inherent characteristics of the data. One is there is a similarity aspect, other is the dissimilarity aspect. And so to examine the dissimilarity aspect, we consider the variance. And this is the variance that provides us the maximum of the information. So actually the statistics is there or analytics is there just because of this variance. So this is the variation. Now we examine what are the reasons for this variation. So let us consider case number 2 and case number 3. For Q3 sales, one value is 53, other value is 69. Now we examine what is the reason for this difference vis-a-vis location. So we see that the case number 2 belongs to the location 2, that is the eastern region, and case number 3 belongs to the 1, that is the northern region. Since regions are different, so here sales appears to be different. So the reason for the difference between 53 and 69, or reason for this variation is because of different region, or that is known as between group or between location variation. So this is one of the reason. Now, instead of 2 and 3, if we compare 1 and 2, both belongs to the location 2, both are eastern region outlets. But one value is 62, other value is 53. So the reason for this variation is within group or within class variation. And the reason is apart from location, means there must be some other reason because of which there is a difference. Is that okay? So this concept is known as analysis of variance. Now I am explaining this on the whiteboard, so to make these concepts clear. Okay. So we say that there is a variation, and that variation is known as total variation. We are considering Q3 sales. This is known as total variation. Right? So this there is variation, and that is known as total variation. Now, if we try to know what are the reasons for the variation, there is one that is known as between group. This is a generic word, or here we can write between location variation, and there is another one that is within group or within location variation, right? And this ratio of these two variation, that is between group variation in the numerator and within group variation in the denominator. Now suppose between group variation is high, right? Between group variation is high means values in the northern are much different from values in the eastern, are much different from values in the western, and so on. Suppose between group variation is high. So numerator is much higher as compared to denominator. So the value of f would be much greater than 1. Now this is much greater than 1, so its corresponding p-value or significance f would be small. And if this p-value or significance f is less than 0.05, so we say that we reject H naught at 5% level. Right? So actually we are performing this test through analysis of variance. So this is known as analysis of variance. And why one way? Because here we are interpreting the variation according to location only. Means we are breaking the variation with respect to one factor only. So that's why this is known as one-way ANOVA. Is that okay? This I will be doing on SPSS. So why this is known as ANOVA and why this is used for mean testing? Is it clear? Is it clear?
Yes.
Right. Now, we move forward. If we don't reject H naught, then things becomes very simple. We will simply say that there is no difference. But suppose if H naught is being rejected. Now H naught is being rejected. Just a moment. So the question arises, which mu is different? So we examine which pair of values are different. So there may be one pair or there may be more than one pair also. So for that purpose, we perform post hoc analysis or multiple comparison analysis. So the existence of the post hoc analysis or multiple comparison analysis is only in the case when H naught is being rejected. Right? So let me explain that a bit more. So what is the concept of the post hoc or multiple comparison analysis? Here we compare two groups. Like in our case, there are four: northern, eastern, western, and southern. So there will be n C2 pairs, means there will be four C2 pairs, that is equals to 6. What are these pairs? N is being compared with eastern, western, and southern 3. Then eastern is compared with western and southern 2. And lastly, western is compared with southern. Right? So there will be 6 such combinations. And here we perform the comparison of two groups only. Means we are comparing mu1 and mu2. So for this comparison, we require two concepts. Like here, earlier in the independent sample t-test, we can go for equal variance case or we can go for unequal variance case, which is being decided by Levenet test. If variances are equal, then we go with one of the equal variances test. Like I am taking one, that is the Tukey highly significant difference test. And if variances are unequal, then we select one, that is Tamhane test. Let me correct the spelling. We will be interpreting Tamhane. Okay. So this I will be showing you on SPSS. So after that, I will take the question if there are some. So that will be a revision. And then we will be taking the questions. So A spacer sheet is there, class. We go to analyze, then we go to compare mean, and then we go to one-way ANOVA. This is one-way ANOVA. Suppose the test variable is the third quarter, so we will be selecting the third quarter. This is a dependent list. And the groups are being created by the location, so location are being entered into the factor. Right? Then in the post hoc, as I have mentioned, it will be used as multiple comparison test only if H0 is rejected. Here we have two options, one for equal variance, one for unequal variance. So we select one from the equal variance and we select one from unequal variance. Obviously, we are not interpreting both Tukey and Tamhane, we are interpreting only one. If variances comes out to be equal, then we will be interpreting one from the equal variance, say Tukey. And if variances are not comes out to be equal, they are examined as unequal, then we will be interpreting Tamhane. Okay, we will be interpreting only one. We press continue, and in the option we select descriptive that provides us mean, etc. We also select homogeneity of variance, that is through the Leibniz test. It is used to decide whether we are using Tukey or we are using Tamhane. If we want a graph, then we will be selecting mean plot. So I am not taking that. We continue and press OK. So any question up to this point? So I can take those questions. Otherwise, we will move forward. Any question? Yes, any question?
No, sir. Fine.
Okay. How I have calculated NC2? Let me show you. NC2. NC2 is for the combination formula. This is n into n minus 1 divided by 2. So there are 4 into 4 minus 1 divided by 2. So this would be 4 into 3 by 2, that is 6. Is that okay, Mr. No? Okay, right. I will be showing the output again. So now I'm coming back to the output. So output is there. So the first table that is to be interpreted is the ANOVA table. You people can have a screenshot. So this ANOVA is the analysis of variance. Here the total variation is being divided into two parts. One is between group, other is within group. Now the contribution of the between group is 394.268 and the contribution of the within group is 36. 394 is much greater than 36. So their ratio 394 divided by 36, we are getting 10.771. That is much higher as compared to 1. So the p value is 0.000. This p value is less than 0.05. So we are rejecting H0. So we are rejecting that samples have equal mean. So is it okay, class? Is it okay? Is it okay?
Yes.
Okay.
Yes.
Right. So here, you people can have a screenshot of this. Now I am interpreting ANOVA. I am changing the PPT ANOVA. Now I am writing down the output with the real values. Right. Remember, the H0 is mu1, the mu n equals to mu e equals to mu w equals to mu s. And H1 is at least one mu is different. So from ANOVA, the p-value is 0.000, which is less than 0.05. So we reject H naught. Reject H naught means all mu's are not same. Since all mu's are not same, so we will be using post hoc test, which is multiple comparison. Okay, so the question arises whether we should go for equal variance case, that is for Tukey, or we should go for the Tamhane. So here we will be interpreting the Levenet test. I am just writing down the Levenet test, and we are considering the p-value of the Levenet test. So now you people can have a screenshot of test of homogeneity of variance. As we see here, the p-value or the significance of the Levenet test is 0.043, which is less than 0.05. Since this is less than 0.05, so we are saying that variances are unequal. Is that okay? You people can have a screenshot of test of homogeneity of variance. Done? Done? And have a screenshot of this post hoc test also. This is post hoc or multiple comparison test. On the first part, we have Tukey highly significant difference, that is for equal variance, and the second part, that is Tamhane. Only the values would be different, but the columns remains the same, and we will be following this significance. Obviously, here we will be following Tamhane only. So you people can have a screenshot of this also. Right? Have a screenshot of multiple comparison also. So that would be easy for the referencing purpose. Is it done? Hello?
Yes, sir.
Okay. So first we are interpreting this homogeneity of variances as per the Leibniz statistics. So I am writing down on my whiteboard. So whiteboard is there, class?
Yes, sir.
Yes, sir.
Right. So as per the Leibniz test, the significance is 0.043. That is less than 0.05. It means we will be interpreting unequal variances case. Means we are interpreting Tamhane's values. Okay. So now I am using the Tamhane values. You people have a screenshot. So here we will be having stock test or multiple comparison. Okay, where we will be using hypothesis as mu1 equals to mu2 versus h1 as mu1 not equals to mu2. So there will be 6 pairs. And what are these pairs? One is we are comparing northern and southern. This is the pair. And that is being done by the p-value or the significance. Then we decide. So one is comparing northern with, sorry, I will be following the sequence. So the first is the comparison of northern and eastern. This is one. The second one is comparing northern with western. The third is comparing northern with southern. Now these are the symmetric tests. So once we compare northern with eastern, it is immaterial to compare eastern with northern. We will be getting the same result. So the next one is we are comparing eastern and western. Then we are comparing eastern and southern. Right? Now we come to the western part. Western has already been compared with northern. Western has already been compared with eastern. So we are not taking. So this is the last case that western is being compared with southern. And related to the southern, southern has been compared with northern, southern has been compared with eastern, southern has been compared with western. Is that okay? So there will be these 6 pairs. Is that okay, class?
Yes, sir.
Yes, sir.
And if variances are equal, then we are taking the Tukey values, the significance column. And if variances are unequal, then we are using the Tamhane values. Just for the reference, I am showing that values again. Right? If variances are equal, then when we compare eastern and northern and eastern, we will be using the p-value of 0.002. But since variances are not equal, so we are interpreting Tamhane. So when we compare northern with eastern, we will be taking the p-value of significance as 0.044. When we compare northern and western, we will be taking the value 0.014. When we are comparing northern with southern, we are taking the significance as 0.000. As we have already compared northern with eastern, so if we compare eastern with northern, then only the repetition is there. As you see, we are getting the same p-value. That's why there are only 6 pairs. So now we will be using those values for the final interpretation. Now, you people have the screenshot. So I am writing down the values when we compare northern with eastern. What is the p-value? This is 0.044. Now this value is less than 0.05. So we reject H0. This H0 means northern is not equals to eastern. Now when we compare northern with western, the p-value is 0.014, which is less than 0.05. So again we reject H0. Means northern and western sales are not same. And when we compare northern with southern, what is the p-value? 0.000, which is less than 0.05. So again we reject H0. Means they are not same. So from the first 3 analysis, we say northern is different from eastern, northern is different from western, northern is different from southern. So northern is different from all other. This is the first thing. Now when we compare eastern and western, so the p-value is 0.979, which is greater than 0.05. So we don't reject, we accept H0. So we say that there is insignificant difference between eastern and western. Now if we compare eastern with southern, the p-value is 0.012, which is less than 0.05. So again we reject H0. And the next value is western to southern. The value is 0.033. This is again less than 0.05. We reject H0. So what we say, northern is different from all other. So one block is of northern. Eastern and western are same, but eastern is different from northern. Eastern is different from southern, right? And western is also different from northern. Western is also different from southern. So eastern and western remaining the same, they are equal, but they are different from northern and southern. So eastern and western are supposedly same. So this is the another group. And southern is different from northern, southern is different from eastern, southern is different from western. So southern is standing separately. So among the 4 regions, there are actually 3 blocks: northern one, southern two, and eastern and western, another one. Now, I haven't created the hierarchy. I am just saying that there are 3 blocks. So any question up to this point? If there, kindly ask. Any question? Or is it clear? Okay. Okay. Right. So
So one question is that
the importance of the F value. Importance of F value is if F is the ratio of between group variation, that is the explained variation, and the within group variation, that is the unexplained variation. So higher the value of F, right, F will go towards the edge, so the P value would be low. So this is the importance of the F value. Means if F value is low, then P value would be high. So the things won't be rejected, that would be accepted. Is it clear, Mr. No? Okay. So now we will be creating the final hierarchy. So for that purpose, I am taking back to the output part. And now we will be taking this descriptive table. So you people can have a screenshot of this descriptive table also. This is used for final creation. I am just writing down the values as per this table, the mean values. The mean sale for the northern is 70.64. The mean sale for the eastern is 62. It is there. Mean sale for the western is 60.74. I'm writing down from here only. And mean sale for the southern is 62.42. Right? So you people must have the screenshot. Now I'm going back to my whiteboard. Okay. So now, as we look for these values, northern is standing separately and the value of the northern is highest. So at the first position, we have northern outlets, means northern outlets are giving the highest sale. Now at the second position, as from the sample value comes the eastern, but we have just analyzed that there is insignificant difference. Means these two values are insignificantly different, so they are supposed to be same for the population values. So at the second position, we have eastern and western region. And southern is again standing separately apart from northern and eastern and western. So at the third position, we have only the southern region. So this is the hierarchy. So this is all about one-way ANOVA. So if you have any question, you can take. And all these things are there in the notes. Like here in the ANOVA, I have explained the ANOVA post hoc analysis. So we have done up to this level. If there are any question, kindly ask. Otherwise, we are moving forward. Yes, participants? Any question? Hello? Okay. So suppose there is no questions. Now I moving forward. So far we are discussing the parametric test. Now we are moving to non-parametric test. Right? They are much similar to the, yes, Miss Ramya, you have raised hand. Yes, Miss Ramya, please ask. Hello. Anyway, so we are discussing non-parametric tests. So these tests are used when the normality assumption about the population distribution cannot be made. Yesterday, I have told how we examine whether the distribution is following normal or not. So if normality assumptions are there, we will be going with the parametric test. Otherwise, we have to go for the non-parametric test. So non-parametric tests are less efficient, but can be used in most general situations. Right? So this statement is actually related to interval and ratio scale. So in the interval and ratio scale, we examine whether there is normality or not. But if our data is in the form of nominal scale and oblique or ordinal scale, then we will always use non-parametric test. Is that okay? Right. Like the binomial test, we examine, this is for the non-metric or the categorical data, means P equals to P naught. Means we say that rural and urban outlets are in equal amount. So we examine, um, we have only two categories, so this is used for the binomial test. If we have more than two category, we will be using chi-square test, means more than two category. A two independent sample test, that is a Mann-Whitney test. So Mann-Whitney test is parallel to two independent sample t-tests. The same type of dialog box and same type of interpretation. This Wilcoxon test is parallel to paired sample t-test that we have discussed. I will be showing them also. And this Ruskell-Wallace test is parallel to k-independent sample test or one-way test, one-way ANOVA test. These are the parallel tests that are available. Now, on this data set, I am demonstrating these tests, right? Just for the time being, assume that they are not following normal distribution, right? So just for the demonstration purpose, I am explaining these tests. Obviously, this binomial test would be applied on type where we examine whether there is equal presence or not of urban outlets and rural outlets. And for the chi-square test, we are examining whether there is equal presence in eastern, western, northern, and southern region. So first I am doing these two tests. Anomal means two difference. So for that purpose, I am taking slide. Just a moment. So first, I am demonstrating the binomial test. This is used to examine that there is an equal presence of rural or urban and rural outlets. Means there are only two categories. That's why there is a name, that binomial test. What we examine P1, P rural, P urban equals to P rural. Means proportion of urban outlets equals to proportion of rural outlet. Since there are only two categories, so it can be done by this way also, that H naught P urban percentage is 50% or 0.5. Obviously, urban is 50%, then rural will also be 50%. So this is the binomial test we are going to use. So here I am demonstrating this test. So we go to analyze, then we go to non-parametric test, then we go to the legacy dialog. Here chi-square is used for more than 2 category, and for 2 category I am using the binomial test. So I am selecting the binomial. And the test variable is type of the outlet. I am selecting the type of the outlet. And here we are examining whether there is equal presence of rural and urban. So the test proportion is 50% or 0.5. So this is the test. I am clicking OK. Right. Now there are 37 outlets belonging to urban and 23 outlets belonging to rural. We examine whether there is equal presence or not. So if you look for the p-value, the p-value is 0.092, which is greater than 0.05. So we are not rejecting. We can say that there is insignificant difference between the presence of urban outlets and the rural outlets. The two number of outlets are same. So is it clear, class? Is binomial test is clear? Hello?
Yes, sir.
Right. So I am just writing on my whiteboard. So this is H0 versus H1. H1 is proportion of urban is not equal to the proportion of rural. Here the p-value comes out to be 0.092. This is for two-tail, and we are taking the two-tail test, and that is greater than 0.05. So we do not reject. Means there is equal presence or insignificant different presence of outlets in urban area and rural area. Now simultaneously I will be discussing the chi-square test, where we have more than 2 categories. So here we examine equal presence of outlets in 4 regions or 4 locations. So we will be examining H0 as proportion of outlet in the northern is equal to proportion of outlet in the eastern is equal to proportion of outlet in the western is equal to proportion of outlet in the southern. We will be using chi-square test. This I am showing you. I am moving a bit fast so that we have covered all these things. So we go to analyze. A spacer sheet is there, class?
Yes, sir.
Then we use chi-square test. Now we are selecting the location. Here H0 is all category equal, and if we press OK. So there are 11 outlets from the northern, 21 outlets from the eastern, 23 outlets are from the western, and 5 outlets from the southern. And as per the p-value is 0.002, so which is less than 0.05. So I'm just writing down. It will be shared later on. So here the significance is 0.002, which is less than 0.05. So we reject H0. Reject H0 means not equal presence. I am not sharing the slide, but from the output, is it clear? So is it done? Is it done?
Yes, sir.
Yes, sir.
Now I am using the another test. Let me show the slides just once so that I will be covering 2 or 3 simultaneously. After that, I will be demonstrating these 2 tests. That is the Mann-Whitney test, which is parallel to 2 independent sample tests. Here we are comparing the average sale of rural outlets and the average sale of the urban outlets. Right? If data distribution is not normal, if that is normal, we will be using independent sample t-test. And for the two related sample or the Wilcoxon test, which is parallel to the pair t-test, we will be using for success of advertisement scheme, means we are comparing average sale of the second quarter with the average sale of first quarter. And for the k-independent sample or the Ruskell-Wallis test, which is parallel to one-way ANOVA, here we are examining whether four regions are having equal sales or not. Means we are comparing northern sales with the eastern sale, with the western sale, with the southern sale. Obviously, here in all these cases, we are assuming that data distribution is normal. Obviously, the distribution is normal. We will be using parametric tests. Right? So I will be demonstrating these three tests. So if there is any question, kindly ask. Otherwise, I will be moving to SPSS sheet, demonstrating these three tests in a sequence. Any question is there?
Sir,
Yes.
while determining the objectives itself, should we determine the test that we are going to make, sir?
Yes. Yes. It also depends upon whether the assumptions are being fulfilled or not. So whenever we frame the objective, suppose the objective is related to relationship, then obviously we are going for the
Correlation.
regression, right?
Uh-huh.
So everything is related.
Oh,
Right. There is one more question: if we have different age groups and level of literacy. So for that purpose, we will be using cross-tab test. So if the time permits, I will be demonstrating all these. Right. So let me
okay.
show you all these tests. And I will be taking 5 more minutes. Right. First, we will be demonstrating the Mann-Whitney test, which is parallel to two independent sample t-tests. So we go to analyze, then we go to non-parametric, and through the non-parametric, we go to two independent sample tests. This is the Mann-Whitney test. As you see, this dialog box is very similar to the dialog box of independent sample t-test. Here the test variable is sales of the outlet in the first, or sales of the outlet in the third region that we have selected earlier. The grouping variable is from the type of outlet, and the type of outlet are 1 and 2, which we did earlier also. The same thing except the test. And this is the Mann-Whitney test. So this is the output. Here the p-value is 0.052, which is greater than 0.05. So we are not rejecting this when we compare urban and rural outlets. So we say that there is insignificant difference between urban and outlet. But if we consider the one-tail test, so we divide 0.052 by 2. So we are getting 0.026, which is less than 0.05. So we say that we are rejecting H0. Then in that case, we say that rural outlets are giving higher sale as compared to urban outlet. So it depends upon H1. So this is the first test. After that, I am demonstrating the test related to success of advertisement campaign. So that was pair t-test. Here I am using Wilcoxon test. So that is the two related tests. So here the name of the test is the Wilcoxon test. And two pairs are sale of the outlet in the first quarter and sale of the outlet in the second quarter. So as you see here, this is a Wilcoxon signed rank test. The p-value is 0.896, which is greater than 0.05. So we say that there is insignificant difference between Q1 sale and Q2 sale. So advertisement campaign is not a success if we use the non-parametric test. And after that, parallel to ANOVA, that was a Ruskell-Wallis test. So for that, we go to analyze, then we go to non-parametric test, then we go to the legacy, and I will be selecting k-independent sample test. Remember the name, that was the Ruskell-Wallis test. So I am applying this for the third quarter data that we did in ANOVA. And for the grouping variable, I will be selecting location, which has more than 2, and we are defining the range. The codes are from 1 to 4. So we are selecting from 1 to 4. So this is the grouping variable. This is the Ruskell-Wallis test, which is parallel to ANOVA. So in ANOVA also we got the p-value as 0.000. Here also we are getting the p-value as 0.000, which is less than 0.05. So we say that there is significant difference between northern region outlets, eastern region outlet, western region outlet, and southern region outlet with respect to third quarter sale. So I have explained these three tests. So is it okay? I have to interpret one more, that is the cross tabulation or chi-square test of independence. That was the question from a participant. But before that, I have explained these three tests in a bit fast manner. But now you people have some background, so hopefully there won't be any problem. So even if there is some problem, kindly ask. Or we should move forward to the last part, that is a cross tab. That was question from Bibin Bose. Any question? Any question?
Sir, what is the difference between this chi-square test and Ruskell-Wallis test? Both are analyzing multiple variables.
No. Chi-square. Let me put this on PPT. So PPT is there. The chi-square test is used for categorical data. Remember, this is a categorical data where we are comparing the proportion. Means there is equal presence in eastern, western. So we are actually counting the data. Why the Ruskell-Wallis test is just parallel to ANOVA. So this is used for metric scale. But the only thing is, it is not following the normal distribution. So this Ruskell-Wallis, so all these tests are used for metric data, where normality assumption cannot be fulfilled. And these first two tests are used for categorical data. It is being mentioned here. This is for non-metric data. So the difference is clear. One is the test of proportion and other is the test of mean.
Okay,
Is
sir.
it clear?
Yes, sir.
Okay. Now, I'm taking just 5 more minutes. I'm explaining the cross-tab analysis. Cross-tab analysis is chi-square test of independence. Here we examine whether two attributes are independent or not. I will be explaining efficiency of test later on. Okay, let me cover the first one, then I will be taking the next questions. Right? Means the question was whether different age groups and literacy are related or not. Right? So here the two attributes are different. Two attributes are, like in that case, the age group, and other attributes is the level of literacy. They are related or not. So for that purpose, we use cross-tab analysis or chi-square test of independence. So this is the formula. In our present example, we can have whether the presence in northern, eastern, western, southern, and presence in urban and rural are related. Means with different location, whether the bifurcation of urban and rural are related or not. So here we have two attributes. One is the location, means we are examining whether location and type are independent or related. Right? So like the question by Mr. Bipin, the two attributes are age group and level of literacy. Here the two attributes in our example can be the location versus the type. So I am just demonstrating this test, and after that we will be taking another questions. So Okay. So we go to analyze. Remember, we are performing cross-tab analysis. So we go to analyze, then we go to descriptive statistics, and then we go to cross-tab. So cross-tab is here, which is the chi-square test of independence. This is different from non-parametric chi-square. So we go to analyze, then we go to descriptive statistics, then we go to cross-tab. Here one is the location, one variable is location, another variable is type of outlet. So this is the type. And in the statistics, I am taking the chi-square test. So we select the chi-square, then we press continue, and then we press OK. So this is the chi-square test. As you see here, the p-value is 0.072, which is greater than 0.05. So we are not rejecting the null hypothesis that two attributes are independent. We are accepting the hypothesis, so we say that the location and type of outlet are independent. Means we don't have undue distribution of rural or urban in some location or not. Right? So let me write this output through the cross-tab analysis. So here, as per this analysis, the significance is 0.072, which is greater than 0.05. So we are not rejecting H0. Do not reject H0. Means two attributes are independent. Means location and type are independent. Okay, so had this test being run for age group and level of literacy, and if the p-value comes out to be greater than 0.05, so we say that they are independent, they are not related. Okay, so this is the test. Now there are two more questions. What do we mean by efficiency of test? It is related to the power of test. Power of test means the demarcation, means it has lower error of committing. Remember, there were two errors. One is alpha and another is beta. So normally we fix alpha and we try to minimize beta. When we try to minimize beta, that is known, the reverse of the beta, that is 1 minus beta, is known as power. So a test is having higher power, that test is more efficient. This is a question from Mr. Shahid. And from Priyam, the question is, if we analyzing the effect of a particular situation for long term as well as short term. So it depends upon whether we are examining the relationship or we are examining these two. If there are only two categories, one is the long term effect, other is the short term effect, and you have taken the related sample. So in that case, we will be using pair t-test. Is that okay, Priyam? Okay, because we are putting the same subject for long term and the same subject for the short term, right? So that is used under pair t-test if distribution is normal. If distribution is not normal, so we are using non-parametric test. That was that test we have used was just a moment. That was the Wilcoxon signed rank test that I have just demonstrated. So we have covered all parametric tests as well as all non-parametric tests. So if there are some questions, kindly ask. Yes, any question? I will be sharing all these outputs. Yes, any question or we should call a day?
I think no questions.
Okay, thank you. Okay,
Thank you, sir, for giving hands-on on parametric and non-parametric test. We would like to listen tomorrow again on another topic. Okay, sir.
Thank you. Bye bye. Thank you.